Hi everyone, welcome back to Z Physics. Today we're going to be doing quite a lot of multiple choice question practice. The paper that we're going to be doing is OCR Physics B from June 2018. Now, if you are doing OCR Physics A, this is actually going to be a great opportunity to do some new multiple choice questions on the material. Several questions though will be covering parts of the specification which are not on the OCR Physics A specification, and if that question is not relevant to OCR Physics A, I am going to display a message saying so. Additionally, before we get started, let me just mention that these are not official solutions. These are just my solutions, and I've provided links to the OCR Physics website where you can find both the paper and the official mark scheme. Okay, so let's get started with question 1. Which expression gives a quantity that can be expressed in joules? Well, force times velocity is actually power. So this is an equation that we're familiar with. Power, it can be expressed as force times velocity, which is measured in watts. So that's not going to be the case. I squared times r will also be giving us power. Mass times velocity is momentum, which has units of kilograms meters per second, so it's not going to be c as well. And what we're left with is d. VIT. Now, if you're curious where this comes from, remember power is energy over time, energy is power times time, and because power is V times I, we can also express the energy as V times I times T. So the correct answer is D. Question 2. Which of these ages is estimated correctly? The answer is A. The Earth is approximately 4 billion years old. The universe is approximately 13.8 billion years, and the Earth is approximately 4 billion years old. So it might be worth just keeping that in mind. So 3. How many bits are required to code for 1,300 different levels? Now, each bit obviously will contain 2 possible options, and 2 to the power of 10 is going to give us 1,024 different levels. So if we're doing 1,300, we're going to need 1 more. So the answer is going to be D11. 4. This is quite a good one. We have an image sent from Pluto to Earth is 1024 by 1024 pixels. Each pixel is coded by 12 bits. The data is transferred at a rate of 200 bytes per second. Remember, 1 byte is equal to 8 bits. And it's actually a tricky question, obviously, because the words are so similar. This here is given in bits, this here is given in 200. So each image is 124 by 124, and each of them contains 12 bits. And what I've done is I've simply divided that by 200 times 8, which is 1,600 bits. Just to convert the bytes into bits, that gives me 7864, and this is 7864 bits per second. What I've done then is just divided by 60 to give me 131 minutes. So the correct answer is C. Question 5. We have a boat which travels to the east with a velocity of 12 meters per second. I have a current which is pushing the boat towards the north with a velocity of 5 meters per second. What is the magnitude of the resultant velocity? We can directly use Pythagoras' theorem. So I've got the resultant r. R is going to be equal to 5 squared plus 12 squared, and r will be the square root of 5 squared plus 12 squared, which is 13. So the correct answer is B. Question 6. We have a weight of 20 newtons, which is suspended from a steel wire. We're given quite a lot of details on essentially all of the Young's modulus equation. By the way, I've just called Young's modulus as Ym. In your formula booklet, it is actually called E. I quite like using Ym for Young's modulus, simply because, let me just say that I'm going to write that here because E can sometimes be confused with energy. But anyways, Young's modulus is stress over strain. Remember, the stress is the force per unit cross-sectional area, and your strain is your extension divided by the original length. Now, because when we're dividing by a fraction, that's the same as multiplying by the inverse, F over A will then be multiplied by L divided by X. Rearranging for X, we're going to find that X is F times L divided by A times Young's modulus. Plugging in all the numbers, we're going to find 3.4 times 10 to the power of minus 3, which leads us to the correct answer being B. Question 7, we have two circuits which use identical components, and the cells have 0 internal resistance. Now, what is the ratio of the power dissipated in circuit 1 divided by the power dissipated in circuit 2? Well, the first thing we need to do is just the combined resistance. Remember, if we are finding the total resistance in a series circuit, we just add the two resistors. So the total resistance here is 2R. If it's a parallel circuit, R total will be 1 over R plus 1 over R raised to the power of minus 1, which of course is going to give us 2 over R, and then we need to flip the fraction, which means that it's going to be R over 2. If they're in parallel as well, they're equal resistance, this means that always that the resultant resistance is half of it. So if you're quite used to electronics, you could literally just see immediately that the total resistance in the parallel circuit is R over 2. Now, power in general, I'll just write this on the side, is given by V squared divided by R. Given in your formula sheet, if you forget that, one way of remembering it is power is VI, and I is, of course, V over R, so that's V times V divided by R, which leads us to this. So V squared over 2R will divided by V squared over R over 2. Once again, we're going to be playing around with the fractions. Dividing by a fraction is the same as multiplying by the inverse. So what I get is V squared over 2R multiplied by R over 2 divided by V squared, which is the inverse of this fraction. By doing some cancellations and in ratios, we are always going to cancel some of the symbols. That's how all the ratio questions are normally designed. And we're going to get the ratio of a half divided by 2, which of course is a quarter. So the correct answer is A. Question 8. Which combinations of resistors give the lowest total resistance? By far the easiest way of these is just to quickly write those numbers and punch them into your calculators, and you're going to get 220, 475, 366.7 and 280. The trick here is that this resistor is in series with this whole branch, but to find the total resistance of this branch, we need to use the resistance in parallel formula, which is 1 over R plus 1 over the other resistor raised to the power of minus 1. When we calculate those, the lowest total resistance is A as shown. Question 9. Really interesting question. We have a graph, and which statement is correct? The acceleration is 0 at time x. This is definitely correct. Now, why is that? Now, this is a displacement time graph. The gradient is actually the speed. And notice that in this region, around x, the graph is a pure straight line. Now, if the graph is a straight line, that means that the gradient of the tangent is constant, which means that the velocity is constant. But constant velocity, of course, means 0 acceleration. So the correct answer is A. Question 10. So this question has a couple of different ways of solving it. By far the easiest way is to be using the elastic potential energy and set that equal to the kinetic energy. When you compress the spring or you extend it, there's a constant exchange of elastic potential energy to kinetic energy. Set your elastic potential energy equal to your kinetic energy, and you're going to find that a half kx squared, that's your elastic potential energy, is going to equal to a half mv squared. The halves are going to cancel, what you're left with is kx squared is equal to v squared. Rearranging for v, we're going to find this is equal to the square root of kx squared divided by m, which is equal to the square root of 20 times 2.5 centimeters, sorry, which is 2.5 times 10 to the power minus 2 divided by 0.4, which is the mass. That's going to give us 0.18 meters per second. So the correct answer is A. 11. We have an electron that is traveling at a speed of 3.1 times 10 to the power 5 meters per second. What is the kinetic energy in electron volts? Well, let's calculate that. 1/2 mv squared, plug in the value for the electron mass, multiply by the speed carefully, and we're going to get this number. After we divide this number by the elementary charge, we're going to get 0.27 electron volts. Remember, if you're going from joules to electron volts, we divide by the elementary charge. So the correct answer is C. 12, really good one. We have a diagram showing the beta energy spectrum for the emission from a radioactive isotope. Which statement is correct? The maximum energy of beta emissions is about 0.1. Well, this is just the peak of the graph, but what does that actually tell us? That tells us that this is the most common, the most frequent energy emission. So it's not the maximum energy, it's the most frequent one. So this is incorrect. More than half of the beta particles are emitted with less than half of the maximum energy. Now the maximum energy is over here, about just over 1.1, so quite close to 1.2 actually. But so few of those particles are actually emitted. I mean, look at that frequency, it's almost non-existent. However, the peak is over here, way below the half. So definitely part B is the correct one. More than half of the beta particles are emitted with less than half of the maximum energy. An additional way of thinking about it is this kind of goes to here, and that goes down to there, which is less than the half, which is 0.6. Okay, question 13. Really good one. We have a resistor which is being charged up. Now, initially, when you're charging a resistor, when you're charging capacitor, sorry, and the voltage across the resistance is equal to the EMF. So it starts at 12 and then it goes down as the voltage across the capacitor goes up. Have a look at my charging capacitor video in which I go over this in quite a lot of detail. So initially, let me just explain this once again. So you start, initially the voltage is 0 across the capacitor, and here it's going to be 12 because they have to add up to the total EMF, Kirchhoff's second law. Now, as the capacitor is charging, this voltage here is going to drop, and the voltage across the capacitor is going to increase. But immediately after the switch is closed, the PD across the capacitor is going to be 0 because it's uncharged, and the PD across the resistor is going to be the same as the EMF here, which is 12. So the correct answer is D. Now, after about 3 seconds, the key here is, of course, you could use the exponential equation if you wanted to and do quite a lot of calculations and get a correct answer, but I'm going to give you a quick trick. Now, calculate the time constant of this circuit. The time constant is CR. So 1.6 times 10 to the power minus 6, 1.6 microfarads. That's our capacitance. R is 2000. If we see this and we calculate this, it's going to be equal to 3.2 times 10 to the power minus 3 seconds. And that's the time constant of our circuit. Well, 3.2 milliseconds. And if the time constant is that small, if after a time which is, about 1,000 times higher than that, 3 seconds, then you're expecting the capacitor to be fully charged up. Therefore, the PD across the capacitor will be 12 and the PD across the resistor will be 0. Therefore, the correct answer is A. Question 15, quite a good one as well. We have a liquid flows through a tube that has an electrical heater with a constant voltage. Which change will increase the change in temperature with no other changes? We're going to use our favorite equation, delta E is equal to mc delta theta. And remember, because power is energy over time, energy is power times time. So power times time will be mc delta theta. Because power is V times I times T, this will be equal to mc delta theta. Rearranging for delta theta, we're going to find that delta theta is V times I times T divided by mc. Now, if your resistance is decreasing, this means the current is increasing. And if everything else remains the same, delta theta, the change in temperature, will also increase. So question 16, we have a thermistor which is being used in a potential divider circuit. When the circuit temperature is 10 degrees, the reading on the voltmeter is 1 volt. What is the resistance of resistor R? Well, first off, let's do the reading. So when the circuit temperature is 10, then the resistance of the thermistor is going to be 18 kilo ohms. So 18 kilo ohms. Well, that will allow us to calculate the current. All we need to do is divide those two numbers. So 2 divided by 18 is going to give us 0.11 milliamps. You could also, of course, write that as 0.11 times 10 to the power minus 3. And once we have the current that is running through the circuit, this is a series circuit. Remember, I've worked in milliamps and kilo ohms in this case, so if I put this in milliamps here, I'm going to get R in kilo ohms at the end of the equation. But anyways, back to this equation, V will be equal to, V in total for the circuit will be equal to I brackets RT plus R, where this is the total resistance of the circuit. Now, the total voltage is 3, the total current is 0.11 milliamps, R of the thermistor is 18 plus R, which is unknown. Now, 3 over 0.11, that's going to be equal to 18 plus R. So all I've done here is just rearranged by dividing by 0.11. And 27.27, which is 3 divided by 0.11, is going to give us 18 plus R. And R will be approximately 9.27 kilo ohms. So the correct answer is B. Question 17, we have a transformer here, something which is a little bit confusing. So because the transformer is actually drawn, some students, I think, quite often tend to count the numbers of coils, which is fine if there's no further information. However, just below here, they've actually given us the number of turns. So this diagram is not up to scale. There are 200 turns on the primary, and there are 100 turns on the secondary. We're going to use the transformers equation that NS over MP is VS over VP. So there's 100 turns on the secondary, divided by the number of turns on the primary, which is 200. That's going to give us VS over 24, the voltage across the secondary coil. VS will be 24 times 100 divided by 200, which is 12. So there's going to be 12 volts across here. Once we know that there are 12 volts here, we could just use power as voltage times current. I will be P divided by V, which is 36 over 12, which is 3 amps. So the correct answer is B. What is the best estimate for the rate of change of flux in this transformer coil? This is really interesting. Now, because your induced EMF is 12, using Faraday's law, which is given in your formula booklet, the induced EMF is equal to the minus negative rate of change of the magnetic flux linkage. Now, the magnetic flux linkage is just your rate of flux multiplied by the number of turns, which in this case is 100. So what I've done here is I've rearranged for the rate of change of the flux, which is delta phi divided by delta t. And that, of course, is minus your induced EMF divided by the number of turns. I've just taken the magnitude here, even though, strictly speaking, there should be a minus sign here. So that's going to be 12 over 100, which is 0.12. Remember, the units for the flux are Webers. Therefore, the rate of change of flux are going to be Webers per second. So the correct answer is A. Question 19. We have an alpha particle approaching an atomic nucleus, and that is scattered through an angle theta. We're shown the path of the particle, so it's traveling horizontally, and then it gets deflected. Now, why does it get deflected? If a particle is approaching, it gets deflected because there's going to be a repulsive force between the positively charged nucleus and the positively charged alpha particle. The force will depend on the charge of the two objects and will also depend on the distance between them, because that's what Coulomb's law is, that F is equal to QQ over 4 pi epsilon naught r squared. Now, which change on its own would cause the scattering angle to increase? Now, what makes the angle increase is the amount of force. So if there's more of a repulsive force, it's going to be scattered at a higher angle. Let's say it might do something like this if the force is higher. Which out of these would make the force increase? The first one, using an alpha particle with high kinetic energy, will have no effect whatsoever. This will only affect the horizontal velocity of the particle, which has nothing to do with how much it reflects. B, having a smaller offset distance would definitely make a huge difference, because if the particle is, let's say, here, by the time it gets close to the nucleus, is going to be experiencing a much larger force, because when R decreases, the force increases considerably, because the force is inversely proportional to 1 over the distance squared. So the correct answer is B. Question 20 and 21. Which expression gives the time for the particle to complete one circle of its motion? So in this case, your magnetic force QVB is equal to mv squared over r. QB will be equal to mv over r. All I've done here is we just cancel out the v's. Rearranging for v, I get that v is rqb divided by m. Now, because the particle is moving with a circular trajectory, v will actually be distance over the time period. Let's say that this has a radius r. Well, distance over time, that's just the circumference of this circle, which is 2 pi r, divided by the time t. T will then be 2 pi r times m over r qb. The radius cancels out. Interestingly, the radius is the time period is completely independent of the radius, but t will then be 2 pi m divided by qb. Therefore, the correct answer is C. Question 21. A proton and an alpha particle with the same velocity enter the region of constant magnetic flux density. And what is the ratio of the radii of the two particles? Remember, anytime we have a ratio, we are going to cancel some things. So initially, just write down a formula for the radius for the alpha particle, write down a formula for the radius of the proton, and then some quantities are going to cancel, I promise you. Now, in general, the radius is given by the following equation. Remember, QVB, that's your magnetic force, is equal to mv squared over r. Cancelling out the v's and rearranging for r, we get that r is equal to mv divided by qb. For the alpha particle, the mass is going to be 4m, because the alpha particle has essentially 2 protons and 2 neutrons. Each of them have very, very similar mass. So we can approximate this by the mass of the alpha particle being 4m. Multiplied by v divided by twice the charge. It only has twice the charge because protons have a charge which is twice the electron charge, and the neutrons have no charge. This will be divided by mv divided by qb, and look at that. The m's are going to cancel, the v's are going to cancel, the qb's are going to cancel, and all we are left with is 4 divided by 2, which of course is equal to 2, and leading us to the correct answer being C. Question 22, we have a table showing the half-lives of 3 radioactive isotopes. Which statement can be deduced from the information given? The correct answer is D. If the number of atoms in the cobalt and the iridium sources is initially equal, then the iridium source will have the greater initial activity. So if the number of atoms is initially equal between this radioactive source and this radioactive source, the iridium source is going to have the greater initial activity. Now, the most active source will be thallium. Even though it has the highest decay constant, we cannot necessarily say that. The reason is because we don't know how much our initial sample contains. B, because the difference in half-lives, the energy of the particles emitted from the cobalt must be less than the energy of the particles. There isn't necessarily a link between the decay constant and the energy of the particles, so we cannot make that statement. And A, the decay constant of thallium is smaller than that of iridium. I'm afraid that the opposite is true, because the decay constant is actually inversely proportional to the half-life. So the smaller the half-life, the larger the decay constant. So A, B, and C are incorrect. D is correct. Okay, question 23. We have a graph which shows the neutron number N plotted against the proton number Z. Now, which statement about stable nuclei is correct? For elements up to Z is approximately equal to 50, N is approximately equal to Z. Well, no, that's not necessarily the case. You can see that N is equal to Z is actually this line over here, and they start to differ really early on, somewhere around here, around 25 or just under 25, they start to differ significantly, or even just around 20 they start to differ significantly. So A is incorrect. B, elements with Z is approximately equal to 80 have more protons than neutrons. Well, the opposite is true, because at 80 we can see that what actually we can see if we draw this line is that we are going to have a neutron number of about 110. So they're going to have more neutrons than protons. B is incorrect. C, greater N to Z neutron to proton ratio is needed to hold large nuclei because only neutrons take part in the strong nuclear force. This is incorrect. Both neutrons and protons take part in the strong nuclear force. D, greater N to Z ratio is needed to hold large nuclei together because only the nearest neighbor nucleons take part in the strong nuclear force of attraction to balance electrostatic repulsion. That is absolutely correct. We need more neutrons in the higher proton numbers to balance out that extra electrostatic repulsion with the strong nuclear force. So the correct answer is D. Question 24, a bit of projectile motion. We have a ball which is kicked from the horizontal ground at velocity of 15 meters per second at an angle of 20 degrees to the horizontal. How long will the ball remain in air? So the ball is initially kicked and I'm only looking at the vertical direction. So Vy is going to equal to Uy plus At. At the maximum point, the ball will only be moving horizontally, so it will not be moving up or down. Therefore, the final vertical speed right here, only at half of the trajectory, will be 0. 0 will be equal to the initial velocity in the vertical direction, which is 15 sine of 20 degrees. If you think about it, as soon as the ball is kicked, it's going to have, with 15 meters per second, it's going to have two components. This guy is 20, the angle. The vertical velocity will be the opposite, which is 15. sine of 20 degrees minus 9.81, the acceleration times t. Notice because the ball is being slowed down, I've taken a to be minus 9.81. Rearranging for t, we're going to find that t is 15 sine 20 divided by 9.81, which is 0.52 seconds. But this is only the time for about half the trajectory, so we're going to need to times that by 2 in order to get the full time, which is about a second. So the correct answer is B. Question 25. We have a diagram which shows two boats P and Q sailing at a constant velocity towards the finishing line. Which statement is correct? Now, because the finishing line is over here, we're only going to focus on the horizontal speeds of the two boats. Their vertical speed is irrelevant. So in this case, the horizontal speed is given by this vector here, which is 7 cos 30, which is 606, and the horizontal speed of this one here is 5 cos 45, which is 3.53. Time is, because they're moving at constant speed, time is just distance divided by speed. So 500 over 606 gives us 82.5 seconds for the time of boat P, and the time for Q is going to be 500 divided by its horizontal speed, which is 3.53, and that's 141.6 seconds. Take those two numbers away and we're going to get 59.1 seconds. So the correct answer is C. This next question is fantastic and really interesting. So we have two masses M and 4M. If P is the gravitational neutral point between the stars, which ratio is correct for X to Y? Now the gravitational neutral point would mean the two gravitational forces are equal to one another. Remember, the formula in general for a gravitational force is minus gmm over r squared. So I've said one gravitational force equal to the other gravitational force. G4mm, assuming that I've put a little test mass m over here. So the force that this test mass is going to experience from this large planet is going to be G4mm over y squared, because that's the distance. I'm going to set that equal to the force, the magnitude of the force that it's going to experience from this planet M here, which will just be gmm over x squared, because x is the distance from M to P. Almost everything is going to cancel. G is going to cancel. I even didn't write the minus sign because that was going to cancel anyways. M is going to cancel. Little m is going to cancel as well. I can directly rearrange for x squared over y squared, which is going to give me 1 over 4. Remember the square root. So x over y is going to be a half. So the correct answer is B. 27. If P is the center of mass of the two stars, which ratio is correct for X to Y? Well, X to Y will be in the ratio of 4 to 1, because the vast majority of the mass will be concentrated along here. So X to Y will now be equal to 4 to 1. So the correct answer is D. Question 28 about the gravitational potential. So if the gravitational potentials of the two stars are equal, which ratio is correct for X to Y? So the gravitational potential, I'm going to once again remind you of the formula. Vg is given by minus gm divided by r. So for the first star, minus g, rather than m, I'm going to write 4m divided by y will be equal to minus gm over x. What I've done then is I've done some cancellation, and I've rearranged for x by x, placing x here. So I get x over y times g 4m is equal to gm, and the g's and the m's can go. What I'm left with is that x over y is equal to 1 over 4. Question 29. This was a really good one. And it involved quite a lot of calculations. I almost ran out of space when I was solving this one. The electric potential at a distance r from a positive point charge is 450 volts. So I've drawn a little figure over here. I have this charge Q, just call it Q, and right over here, distance r, we have 450 volts. We decrease the distance by 1.5 meters and we get 500 volts. What we're looking for is the value of R. So initially what we need to do is just write some equations that we know. We know that the electric potential in general is given by Q over 4 pi epsilon naught times R. That's all I've done here. So I've written 450 is equal to Q over 4 pi epsilon naught R. I've also written the same for the equation below. 500 is equal to Q over 4 pi epsilon naught divided by R minus 1.5. Let me just extend that division sign just so that there's no confusion. The only way we can solve for this system of two equations is by looking at a common factor between them. So I've taken Q to be that. I've rearranged this equation, this first equation for Q, and what I get is that Q is 450 times 4 pi epsilon naught times R. And what I've done is then I've plugged in this value of Q here in the second equation. So 500 will be Q over 4 pi epsilon naught R minus 1.5, and then I've just rewritten it so that rather than Q, I write 450 times 4 pi epsilon naught R divided by 4 pi epsilon naught R minus 1.5. Look at that, 4 pi epsilon naught, it's going to cancel out. So what I'm left with is now a pretty simple equation. 500 is equal to 450 R divided by R minus 1.5. By far the easiest way to solve this is just to multiply by R minus 1.5. So what I get is that 500 times R minus 1.5 is equal to 450R. Expanding out the brackets, I get the 500R minus 500 times 1.5 gives me 750. It's going to equal to 450R. And rearranging for R, we're going to get that R is equal to 15 meters, with the correct answer being C. Question 30, which is about the relativistic gamma factor 1 over the square root of 1 minus v squared over c squared. Which statement about this factor is correct? It's the speed of sound. Gamma is close to 0. Nope. So the speed of sound is very low. So it's going to have basically no effect. So gamma is going to be very close to 1 if that's the case. B is incorrect as well. So gamma tends to 1 as v tends to c. In fact, this function is undefined. It's starting to tend towards infinity, and at c it is undefined, so this is incorrect. C, gamma predicts the time dilation factor, so moving clocks run slower as v approaches c. Absolutely correct. The correct answer is C. Okay folks, well hopefully you found these multiple choice questions useful. If you have, please consider liking this video and subscribing. Thank you very much for watching, and I shall see you in the next video.